All right, so today we're going to talk about neurotransmitters. This is the second half of 2.1. All right, we've talked about neurons and how they fire. Today we're going to quickly go through neurotransmitters. There's a lot of these. Do need to know all of them and know what they do and what having them is, why we need them, but also what happens when we don't have them. So kind of treat this as a lot of AP psychology, as just more vocab that you need to learn, and just make sure that you understand each one of them. So let's go through them. First and foremost, what are they, right? So a reminder, you flip back a little bit for you. A reminder, if we're looking at neurotransmitters, right, it's on the end of this axon. We get to this axon terminal or terminal button, and on this axon terminal, this little like button thing at the end, we've got these synaptic vesicles. These are like basically little sacs, and inside them, they're holding these neurotransmitters. And this is how communication happens between neurons. So neuron to neuron, after that action potential comes flying down the axon, that electrical impulse, it signals to the terminal buttons, the axon terminal here at the end, to release the goods. And the goods are these neurotransmitters. So these are like what the message actually says. Okay, I often think of them as like emojis, right? You've got this big bucket full of emojis, and it's sending those emojis on to the other side, right? And depending what that emoji is, it depends on what like message it conveys. Okay, so let's go over what those are. So, what are neurotransmitters? They are those chemical messengers, okay? They all follow a particular brain pathway, and these neurotransmitters are all going to operate within a system. And we'll talk about the systems a little bit more later, autonomous, parasympathetic, sympathetic, things like that. But for now, mostly know that these are those little bitty chemical transmitters that are sending messages between neurons. Okay, they're sending messages between neurons. You can see here basically just how different systems send them. They're all following a single pathway, right? Like a certain set of neurotransmitters is going to be utilizing a specific, path of neurons is going to have a specific set of neurotransmitters that they'll be sending. Here's what norepinephrine's path looks like, what dopamine's path looks like, right? Multiple different pieces, the different parts of the brain that we're going to use it. This will all make a lot more sense when we get into the parts of the brain. But for now, recognize that neurotransmitters are these little chemical signalers that neurons use to communicate, basically to send messages to the parts of the brain and tell them what to do. So let's go over what those are, okay? So move through these pretty quickly, but do recognize that you probably need to know these. So acetylcholine or ACH is important mostly for muscle action. That's going to be the one that you'll most likely see. And without acetylcholine, you can have paralysis, and oftentimes your deterioration of your neurons that produce acetylcholine is where Alzheimer's come from. So muscular disorders and paralysis without acetylcholine. Okay, so acetylcholine helps your muscles move, right? Whenever it's time for you to move, whenever you're like your body is telling your hands that they need to do something and function appropriately, it's sending it's acetylcholine carrying neurons are going to be blasting through and saying, hey, let's move. It gives you that fine motor control. And when those neurons break down and get destroyed, that can cause oftentimes be Alzheimer's, or it can eventually cause most disorders of muscles or paralysis. Second, dopamine and serotonin both often are used when talking about emotion. They're rewards of a sort. Dopamine first. This one also deals with muscle control because when we think about like Parkinson's disease is the most common question you'd see about with a lack of dopamine. If you don't have enough dopamine, Parkinson's is the outcome. With too much dopamine, however, you can also see schizophrenia. Okay, so dopamine is it's a like positive emotion inducing neurotransmitter when neurons are releasing dopamine between each other and sending that up to the brain. That feels good, right? We get dopamine from all kinds of things, from talking to people, from petting a dog, from someone liking our picture on Instagram. So there's all kinds of like good things that happen with dopamine. But if we get too much of it, right? And I'm not talking too much like you get too many people liking your pictures. I'm talking like your brain is just constantly firing, sending out dopamine. This is where we're going to see schizophrenia. Parkinson's is an undersupply to the point that people who the medication for Parkinson's to make sure that you maintain muscle control and stop the tremors that you might have is going to be mostly like a dopamine powder, right? Something that you can either eat, snort, or like basically anything that it's a form of dopamine that is going to be quick releasing to give you control over your muscles once again and make them stop twitching. Serotonin, also positive, good mood inducing neurotransmitter. It also deals with our emotions. But it's also released in telling us that it's time to sleep. It's what gives us hunger. It releases sexual arousal. So mostly, serotonin is kind of like an emotion inducing one. The big thing you should probably recognize with serotonin is that if you don't have enough of it, depression is the biggie, right? That's going to be the main one. The main drug that is often used to treat depression is known as an SSRI, selective serotonin reuptake inhibitor, meaning that it blocks off reuptake of serotonin in the axon terminal so that there's more serotonin neurotransmitter, right? The feel good emotion or feel good neurotransmitter bouncing around in the synaptic gap. That's more serotonin neurotransmitter that can be picked up by the dendrites of the next neuron so they can continue to pass on and have those feel good neurotransmitters floating around. Okay, so depression can be caused by an undersupply of serotonin, and that's important to note, right? Because we often treat depression like something just like, oh, if you just have a better attitude, you'll get over it. But in many cases, we should recognize that it's not caused by, it's like, oh, they just don't have the right attitudes. It's caused by a chemical imbalance. It's caused by overactive axon terminals that are like they're uptaking too much serotonin, or you're not releasing enough serotonin. Right. And this is also an issue of like what drugs we need to use for depression. And that's why it's often a trial and error kind of thing. Is it the reuptake that's a problem, or is it just not releasing enough in the first place? And then trying to find the root cause of that. So serotonin, while properly balanced, is good for emotions. It helps us sleep. It causes us to be hungry or not. It regulates that. It regulates our sexual arousal. But with an undersupply, it causes depression, anxiety, or obsessive compulsive disorder. Mostly the most questions you would see with depression, but you could see these others as well. Norepinephrine, this one is like adrenaline is another term for it. Norepinephrine and epinephrine. Mix those two neurotransmitters together. It's how we react to stress. Whenever we are stressed, whenever we are freaking out about something, if you turn the corner and there is a 500-pound bear staring at you, your norepinephrine is going to just blast into your brain, being like, it's go time, right? When you're stressed about things, if you're stressed about an AP Psych test, you probably have some norepinephrine releasing. It makes your heart beat faster. It makes your eyes zone in. It makes your blood pump quicker. It gives you the ability to like run faster and further. Like norepinephrine is an increase in stress, which can be a good thing, right? If you see a bear, you need to be able to get away. So norepinephrine is our like stress response. Also known as adrenaline. But without enough of it, we can see this bipolar disorder where we're constantly swinging back and forth between mania and depression. It's not like every 30 minutes they're either in mania or very depressed. Oftentimes, what it actually looks like is multiple days of mania and then multiple days of depression. And without norepinephrine to regulate that, this is often the result. GABA, this one is having to do with brain activity. There's two of these, GABA and the two G's, both do with brain activity. GABA is what slows down our brain activity, right? And that's important, right? We need to be able to both excite and create and have our brain think, but you also need to turn off your brain, right? Think about the importance of turning off your brain. Whenever you lay down for bed, do you want your brain like constantly firing and thinking about stuff? I do this all the time, right? My brain I feel like I'm constantly thinking and stressing and worrying, wondering about what I need to do next. And I don't know if I have a shortage of GABA, but Without enough GABA is where most insomniacs happen, right? The inability to sleep, just laying in bed with your eyes awake, with your brain racing, can often be a cause of a lack of GABA, right? It can also cause seizures, right? Seizures are an overreaction, basically kind of like overfiring of the brain. GABA can stop that, right? Can stop your brain from overreacting and kind of shorting out. Tremors, anxiety, again, like the brain is overactive. GABA can slow that down. Glutamat's the flip side. We need glutamate is like the food of the brain. It's what pushes our memory. It what gets us going. And if we have too much of it, this up here, then that's where we're. If we have too much of it, it's going to like basically the same thing as GABA. If we have an undersupply of GABA, or we can't sleep, we have seizures. If we have too much glutamate, our brain is overstimulated, and we can once again get seizures. Okay, so they both end up doing the same thing. They both end up with our brain being way too active, overactive. We need to control how active our brain is. So the final one that you'll see is endorphins. These are things that often release when we exercise. Endorphins are a natural painkiller, right? It's a big one when people talk about runner's high. Something that like it took me a long time to get there, but after I got into running and exercising enough, it's a therapy for me now, because after you exercise, your body begins releasing these endorphins, right? Like we as humans, people can run 100 miles in a day. That's insane, right? There are ultra marathoners. They go out there and run 100 miles over the course of a day or two. And they can only do that because their body is releasing these endorphins, and they're evolutionarily designed to do that, right? An endorphin is a natural painkiller that when we're running from something, it's going to help us not focus on pain, right? Like in any half marathon I've ever run, within like by mile 9 or 10, my knees are talking to me, my hips are upset, I've got shin splints. But you get that runner's high, and on like race day, whenever you're actually in the race, you've got the high of running, your endorphins releasing, being surrounded by other people, and you don't really feel it, right? If I go out and run 10, 15 miles tomorrow, it's going to hurt. But if 2 weeks from now I ran 13 miles in an actual race with a bunch of other people, the endorphins of that, the kind of the rush of that is going to be enough that I wouldn't feel the same amount of pain. Okay, so it's a natural painkiller, often involved in pleasure, but we can get addicted to it. Okay, oftentimes opiates are going to release this on a huge level. Running, exercise releases a little bit, but opiates release it in mass, like a blast of endorphins into our system, removing any pain, which is good, right? If you are in the hospital, if you just had surgery, this can be a good thing. But the more that happens, the more we don't produce them on our own. And that blast of pleasure and pain-free at the same time is wildly addictive. And our body begins to stop doing it on our own, but also we demand and want that feeling more and more. So those are the biggies that you need to know. Again, focus on like their very basic function, but oftentimes the questions you'll see will be about their malfunctions, or what happens when you have too much or not enough of them. Okay. Next is thinking about drugs. Right. So we talked a little bit in the last one about how endorphins and opiates can do this. So what is it how is it that drugs, not being a neurotransmitter, basically act like neurotransmitters? And these are because they are either agonists or antagonists. This means that drugs basically act like neurotransmitters. They do the same thing. If you're ever wondering how it is that a drug makes people act a certain way, or why it is that they cause people to do something or feel a certain way, it's because drugs are fake neurotransmitters, right? They instill some form of, they inspire our neurons to fire and communicate. It's like a false alarm, right? They're a fake. They're not real neurotransmitters. Our body isn't naturally. It's a unnaturally putting in something that's telling our neurons to fire a neurotransmitter. And that can have very nasty effects, right? When it's channeled appropriately, it can be used as medication, but oftentimes it can have very, very dangerous effects when not used appropriately. So agonists, as you can see here, like these, if you see these green things, these are like a natural neurotransmitter. And then over here, you're going to have, you see this little like blue, this is going to be a dendrite for a neuron that's going to be it's receiving these neurotransmitters. And what a drug is it's going to be bringing in these little guys. Right? It's not the same. They're different, but they can also be received, and it tricks the receptor. right? This receptor previously had some neurotransmitters floating around, but oftentimes drugs are going to release way more, not of a neurotransmitter, but of something that looks like a neurotransmitter. Right. And when it gets to this, it's going to tell the neuron to continue to fire and continue to blast. So our neurons are constantly sending out more and more neurotransmitters on top of a drug, which has also done the same thing. So it's going to have the same effects. An agonist mimics the effects of a neurotransmitter and makes it fire more. Okay. That's what opiates often are. They produce a high by amplifying arousal and pleasure. Okay, they make us feel more of that. On the flip side, antagonists are drugs that are going to bind to receptors and they're going to block the neurotransmitters from firing or from functioning. Okay, Botox, botulin, both of what those do are kind of like a poison, right? I know Botox is ultimately injecting ourselves with poison, but what we're doing is we're paralyzing ourselves. Right. If you're using Botox, you are paralyzing a small part of your face to stop it from getting wrinkles, right? To stop it from, like, I am a very expressive speaker, and I know that I will get these already at the age of 30 have massive like forehead lines. And if I were to maybe Botox my head, it would stop me from being able to like do all this speaking, but it would freeze me in place and it would stop my head from doing that and keep my skin younger. Not super worried about that, but Botox does this by binding to receptors and stopping it from releasing acetylcholine. Remember, acetylcholine is used for muscle control. It gives us the ability to use those muscles. And when you block the ability to use those muscles, or when you stop your neurons from firing acetylcholine, you can't control those muscles. Okay, and if you do that targeted with Botox, you can do that with specific parts of the face, or whatever it is that you want to lift in, or whatever it is that you want to stop like moving around as much and getting rid of those wrinkles. So Botox would do that. Botulin, often used as a poison that you can receive. Sometimes canned food will give you this if it's improper. It can cause paralysis, again, like on a larger scale, by blocking acetylcholine release. And then in the rainforest, this curare is found on the backs of poisonous frogs. Oftentimes indigenous peoples in the Amazon that's where we get these like darts. You see it down here, right? They like collect this off of frogs, and then their blow darts or arrows, they could scrape into that, and if they hit you with that dart, that's going to block acetylcholine throughout your body, and you would eventually die of suffocation. Right? Your lungs and heart are a muscle, and they are going to be blocked the ability to act, because you're not going to be able to move. Right? They're going to paralyze you with that. Okay? So antagonists block, agonists make you produce more of a neurotransmitter. Okay. And then finally, what happens with these, if you do lots and lots of these drugs, we get either tolerance or withdrawal. Tolerance being that our body and our brain gets used to the drug and we aren't able to function without it. Right. Oftentimes when we talk about people being addicted to a drug, this is what we're talking about. It means that they've developed more and more of a tolerance and their body won't do anything without it. So they need to take more and more and more and more in order to get back to the same amount of high. Right. That's true for on just about any drug. Right. Like people, when they turn 21 and have their first drink, that first drink that they have will affect them a lot more than 15, 20 years later, when they're used to drinking more often. Right. It's like once you build up a tolerance by doing that more, and that can reach a dangerous level. Right. They can reach really dangerous levels because you don't notice and you feel like you need more and more of the drug to do something. When used to just a little bit would do it for you. So withdrawal is the flip side of that. It's that our body rejects and refuses to make any more of something because it figured it had enough already. Right? We get discomfort and we get stress. Oftentimes it means we don't have enough endorphins, because like opiates, for instance, blasts our body with endorphins, and there's so much the body's trying to regulate itself. The body sees that. Neurons are like, oh crap, I didn't know we had this many endorphins. There's way too many. Shut down endorphin production. So at that point, they have way too many, right? And they're going to stop making endorphins for a while. So when you come off of that opiate, you're going to feel like crap. right? People are going to feel terrible because their body will produce no endorphins, no dopamine, serotonin, anything that it's producing, anything that your body produces to make you feel good that drugs do it synthetically, they do it fake. The opiates, when you withdraw from those, your body's going to stop producing that and you're going to feel terrible. And so that's why people want to go back when they get that addiction, right? They stop producing their own endorphins, and it causes that discomfort. Cool. So we're going to call it a day there. Sorry for a little bit of a long one. I told you 2.1 is lengthy, but that is it for neurons and neurotransmitters. Hopefully you've got a decent grasp on this. If not, as always, reach out, talk to me. I want to help. And yeah, we'll call it a day there. Otherwise, I will see you later, fam.